Section 10.2 is going to start our discussion of displaying data. Some of the types of graphs that we're going to encounter start really, really young, like with the little bitty ones at, the Shawnee Early Childhood Center kind of stuff. And then others of them, as we progress, are going to be more things that you see in later middle school. So this is like covering the whole gamut of stuff, kind of like if you've taken geometry and measurement, that entire class. It goes from everything like from early elementary to late middle school, and maybe even a little bit of high school in that class. But this one, as we're going to start with, is one that is done in early childhood. So your pre-K, kindergarten kind of classes. These are called pictographs. So these use a picture to represent tallies within categories. So I very specifically remember my now 8-year-old just a few years ago at the Early Childhood Center doing pictographs. And so very, very relevant. Our example is not relevant to the kindergartners, so that's your warning. An Automobile Club of America considers holiday weekends to start Friday at 6 p.m. and to last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, 80 people from Saturday to Sunday and 100 from Sunday till Monday draw a pictograph of the data. So we wouldn't be using this data with the Early Childhood Center. It's just straight out of your textbook, though. Straight out of your textbook. That's where it came from. Okay, so there's a few details in general when you're doing pictographs that you need to be careful of. It's a good idea to use some kind of a picture that it's easy to split at least into halves. So squares are not good because squares split into a half look kind of like a rectangle, and if you're not drawing it super careful, it's still going to look like a square. All right, so that's not the best image in general. Circles are not bad. We're going to use hearts for this one. Hearts split in half really nicely too. So that's something to keep in mind. So you might be thinking, well, why am I going to have to split anything in half? Well, in this problem, we're going to want to, because we don't want to do whatever our image is to represent a single person, because we'd be drawing 100 and something of them potentially on each line, right? Like that's going to take forever. So we're going to want our pictures to represent multiple people at one time. And if we take a look at the values that are given here, let me highlight them. We have 150, we have 100, and where's my other one? 80. So we need a number that will divide these nicely, or at least close to nicely. And there's a couple of pretty common choices. So whatever we let our image be, what do you think you might want its value to be? To represent how many people? 10. 10's a really good choice. So we can let our heart represent 10 people. Sometimes I'll have people choose 20. I know that doesn't work perfectly for my 150, but you can draw half of an image to represent the half that it would be left over. So since you mentioned 10, we'll do 10, Abby, but 20 also works on this one pretty nicely, okay? The differences on this one split, unfortunately, sort of at a funny mark in between days. So I'm going to write them down as the ending day, but if you want to be a little bit more descriptive and say like the first category is Friday to Saturday, you could do that. I'm just going to label the day that they're sort of calling the end of their day. So we've got 3 of these. We'll go with actually that one was fine. And the top is going to represent what happens from Friday to Saturday, and then from Saturday to Sunday, and then from Sunday to Monday. Okay. And our image, when we draw it, has to be at least a little bit careful. It doesn't have to be super precise, but it needs to be careful. We're going to be drawing some hearts. The hearts need to be about the same size from one to the next. If you draw one heart really big and one heart really little, things start to look like they're represented in a way that's not a fair representation. You also need to draw them orderly. So if I were to draw, let me give you an example. If I were to draw my hearts, and I were to draw these all kind of really close together, and then I were to draw them so that they were, spaced more apart like this, that wouldn't be a fair representation either, because there's sort of an illusion that something's going on that's not. So my images need to kind of line up, and they need to be about the same size shape. So again, if I had done some of these hearts where some of them were smaller than others, right, weird things can happen. So we're not going to do that. Those four hearts are not too bad. So my Saturday number is supposed to be 150 people. So how many hearts am I going to have to draw on Saturday? It would need to have 15. And so even as I say that now, I'm pretty sure my hearts need to be smaller. So I'm just going to shrink them and shift them a little bit. Okay, well, the good news is there was enough space. Okay, and it's the longest one, right? The other two are shorter numbers, so smaller numbers. So the next one is 80. So how many hearts do I need?
8.
I need 8, and they need to line up right underneath the first 8 hearts from the first line. So in that part, I do want to be a little bit careful, right? Here's 1, 2. They're lining up straight underneath. 3, 4, 5, 6, 7, and 8. I copy paste what I'm doing. You can do that on yours too, Abby, because I know you're using electronic stuffs. But for the most part, I'm not looking for it to be exactly exact right, but it needs to look reasonable, right? This looks reasonable. Not all my hearts are perfectly alike, but they're all about the same size and they're lined up. And the last one for Monday needs to be how many hearts? It would be 10. So I have the same 8 that I had before, plus 2 more underneath it. Like that. Now, pictographs need to have a key, which we've already done, that the heart is equal to 10 people. We did that. So whatever you're choosing and whatever size you're making it, make sure it's identified on your graph. The other thing that your pictograph needs to have, and in fact every graph needs to have, is a title that says, what in the world does this mean? Okay? So titles are really important. This graph are representing the deaths on a holiday weekend. And we've already written it once. I'll write it again, but if you didn't write here, it wouldn't be the worst thing in the world because it's already written, where the heart equals 10 people. So somewhere in there it needs to say that your heart equals 10 people. It doesn't have to say it in the title, but it, either there or as a separate key marker. We need a title on every single graph we draw. Okay? All right, does that make sense? So when my daughter did this at school, I'm pretty sure what they were doing is they were counting like hair color or eye color in the classroom, and they were drawing in like boxes or something like that. And they made theirs, instead of making it vertically like we've done, or horizontally like we've done, they made it vertically going up. So their pictograph went, built up on top of each other, like the kind of kids who had blonde hair, who had brown hair, who had black hair, whatever it was, the red hair, I don't know what they did, but it was something like that, or maybe it was eye color. But they were counting like that in the classroom. Maybe a little bit less gruesome details, right? Maybe. Okay, so definitely something you could see at a younger level, pictographs. Our next one is kind of an extension of pictographs. Take something that's very concrete, right? The pictograph is a very concrete picture of what's going on, and it makes it a little less concrete, a little more abstract. And this is called a dot or a line plot. We will call it a dot plot because we're going to use the word line to call some other things line graphs later, and I don't want you to get confused between the two. So these are called dot plots. This is a quick way to display data with fewer than 50 values. Okay, so we could have used this dot plot on the last one because it had fewer than 50 values. All right, so our data set on this one is from a classroom and the mass, kilograms of children. So the mass in kilograms of each child in Mrs. Good's class is as follows. And we're going to make a dot plot for the data. So the kinds of things that we need to identify is we need to identify from our data set the smallest and largest value as sort of our beginning and our end of our dot plot. So what is the smallest value that you see in our dot plot or in our data set? 39. And our largest? 49. Okay, so as we're drawing this, we're going to draw a horizontal line. And on our horizontal line, we're going to start with the smallest value. That's the 39 we just had. And we're going to make a hash mark along this horizontal line at every increment value. 39, 40, 41, 42. If our data were bunched up in such a way or very, very spread out, it will depend on whether I would like label every single hash mark. We might increment it by 5s and only label every 5th one or something like that, depending on if our data were really spread out. This one that's really close together. So we're going to label each of them. As we go, we do want to make sure that things look equally spaced, right? So don't make things look like what you're not intending. That's called, so we talk about like truth in advertising or using statistics to give a false impression. When we manipulate graphs, either like intentionally or unintentionally, that can happen. So we want to be careful that we're not trying to do that. And I should be saying careful that we're trying not to do that. So 43, 44. Okay, so far so good? Okay, what we're going to do is, I know this is called a dot plot. I'm not sure where the word dot comes from because the way that our book presents this to be done is not by putting dots on our graph, but by putting check mark, like X's on our graph. So I'm just going to start with the first data value to show you what I mean, and we're going to go in order, and I'm going to mark them off as I go. So this is the number 40, and we're going to put an X right here above the 40, sort of hovering in midair. Now, kind of like with our hearts on the last one, we want to make sure that every X that we draw is going to be about the same size and that it's even, right? So like because we're going to stack our X's on top of each other within each category as we need to. But as we do this stacking, we want to make sure that, like too high, like if I do this, I don't want this to look the same as 2 here, right? I want to make sure that they're lining up at the same height. So let me take this off. Whoops, that one's back. And we're going to go through here. So I'm going to have 49 and 43. So 49 and 43. 48 and 46. 42 and 49. Okay, so 49 is my first duplicate, so I'm stacking. 39, 47. 39 and 47, 49, 42, 41, 42, 39, 41, 40, 45, 43, 44, and 42. So this gives us a very quick visual glance at sort of where the values bunch up, right? What's the largest value? You can see it at a glance. It's 42, right? I mean, that's like the largest number of kids at that value. We also have several kids at the higher end, right? They're kind of bunching up again over there at 49. Overall, comparative to the first to the second half, more of the kids are on the lower half of the graph in general. There's this sort of gap in between where there's just one kid showing up. There might be places on your graph and given a certain data set that don't have an X in their line at all. Like that's okay too. And then every graph needs a title. So we need to title this. I don't care where you put the title. If you want to put it above, to the side, beneath, it just needs to be present. So we do need to make sure that any units are present as well. So for example, on this one, it's the mass in kilograms. So we want to make sure we're specifying in kilograms of children in Miss Good's class.
What if we were just to say the mass of children?
So try to be more specific rather than less, because this isn't all children. It's a specific grouping of children that we're talking about. So specifying the classroom, when if it's in the information you're given, it should be in the details of your title.
Okay.
Yeah. Okay, any other questions on that one? Okay, so this is still early grade school kind of stuff, right? Creating these kinds of charts. Stem and leaf plots are going to be looking more like upper elementary to early middle school. These are akin to dot plots. They're drawn vertically though. The numbers on the left are called stems and on the right are called leaves. Stem and leaf plots do a really good job of displaying grade kind of data. That is what I've seen them used the most for. I had a teacher along the way who, after every test, would actually show the grade disbursement as a stem and leaf plot to the whole class. Like, she didn't tell who did what grades, right? It was just a visual to see how the class did as a whole. And so this is a data set this is actual data from a class that I had. So this is the first exam in a pop and stat class, but it was before we called it that, I don't know, like 10 years ago. And we're going to create a stem and leaf plot for this data. So it's kind of like on the last one, we identify the highest value and the lowest value as reference points. So what is the largest value and the smallest value of this data set?
94 and 43.
Okay, there's 94, and there's 43. So what that tells us is that when we're creating our stem and leaves, the stems are the tens digit. The smallest tens digit was a 4. So I'm going to start it on the left-hand side with the 4, and I'm not going to skip anything. 5, 6, 7, 8, and 9. And if you don't want to do it that way, you can start with 9 and go down to 4. It doesn't matter whether you start with the smallest and go to the biggest or biggest to smallest. I've seen it done both ways. The first time we do this, we're just going to put the data in, and then the second time we do it, we're going to organize the data. If you can put it in and organize the data all at the same time, go for it. I think that's a lot to take in at the same time and not just mess it up anyway, so I usually just do it in 2 steps. So let me show you what I mean. I'm going to go down the line like I did with Mrs. Good's class, and I'm just going to write the values in. So 87 means on the 8 row, I'm going to write a 7. That's the number 87. I have 94, so on the 90s row, I'm going to write a 4. And the first time I don't have to worry about being neat and tidy. I don't need to make sure that all my numbers are the same width apart or none of that like that. I'm just trying to get the data on the lines. So I have 82 and 89. I have 67 and 90. I have 74 and 87. 89, 76. 58, 43. 53 and 80. 94, 77. 74 and 90. Okay, so one of the things, even without going any further, that this shows you from this picture is kind of where the grades bunch up, right? So these are my A's, my B's, my C's from the bottom up. You know, I mean, there's definitely more A's, B's, and C's than there are D's and F's. That's good, right? But it's more helpful when we're working with some data later on to have these actually in order along those leaves as well, not just within the stem. So we're going to draw the picture one more time. We're going to have the same stems on the left. So 4, 5, 6, 7, 8, and 9. I guess I made them smaller this time, whatever. So I'm going to write them in order now. On 43, there's only one number, so I just have my 3. But then on the 50s row, I have an 8 and a 3, and I'm going to put them in order, so it's 3 and then 8. And then I have the 67, that's just one number. And you'll notice as I do this, I am being careful to line things up. You will be able to tell more when I get to the 7s and the 8s that that's happening. So on the row of 7s, I have 2 4s, a 6, and a 7. So I'm doing 4, 4, 6, and 7. And it's almost like there's these invisible, and sometimes people like to use grids, you know, these invisible grid lines that are going between these. Those are terrible. But something like that, you know, where they're lining up. Okay, so they're not there. They're invisible, but they're lining up. The 8s, the smallest 8s is 0. And then I have 2, 7, 7, 9, 9. And then on the 90s, I've got 2 zeros and 2 4s. Okay, so there's a stem and leaf plot. I still need a title. And again, whether you do it within the title or as a separate piece, we need a key that says what in the world this means. So I'll do it within my title so you can see how that would look, but you could write it separately if you wished. These are the grades on a first exam. And on this one, it's pretty vague. Like, that's all it says in our description. I told you a little bit more because this is my data, but we're just using the data that's, the description that's given, that's it. But we need to talk about what these mean. And so we need to pick some data value. It doesn't matter which one we pick, but it is not helpful to pick one that repeats. So for example, if I had the value of, say, 77 here, I don't want to put that as my example where 7/7 is 77. Because the numbers match, and that's not real clear what we're talking about in terms of my values. So it's easier to pick something. I'm just going to use the 4 and the 3. So this is where 4/3 is a grade of 43. Does that make sense? So that I can specify that the tens digit is lining up with the value that's on the left and the ones digit with the value on the right. And that may not seem like a big deal right now. It might be like, well, obviously. But you're going to very quickly see in a moment why it matters on another graph, okay? So our final graph is the second one, or display is the second one, because the first one was sort of an intermediate step. If you can skip this intermediate step to go to that one, fabulous. I usually just draw them both out. All right, any questions on that one? Okay, so the next one is actually called a back-to-back stem and leaf plot. So it is a stem and leaf plot, but what it does is it takes 2 stem and leaf plots and it combines them, and it's used to show data sets in comparison. So one of them is going to have leaves out to the right, like the one we just did, one of the 2 data sets. The other one is going to have its leaves going to the left. Okay? So for starters, let's draw the data set, the stem and leaf plot for this data set that's for the second exam. So these are the grades on a second exam, and we're going to do just like what we did on the first exam. Okay, so right now I'm just drawing out the data set. And then we're going to put them together into the back-to-back stem and leaf plot. So first data set, what's my smallest value? What's my largest? 64.99. So I don't need quite as many stems as I did before. 6, 7, 8, and 9. I'm going to go down the list. I'm going to go top to bottom this time. So 93, 96, 98, 66, 67, 82, 92, 85, 64, 81, 86, 72, 96, 95, 99, 95, and finally 94, 74. Okay, so far so good. This is better than the second that second test, isn't it? And it really was the second test from the first test data. These were the same class. So they either learned how to take a test better or take my tests better, or they just understood the material better. You don't ever always know exactly why, but definitely it's a better test. I'm going to go ahead and draw the stem and leaf plot where it includes all the stems from over here, because I'm going to be putting these pieces together in a minute. So I'm going to start my stem and leaf plot with the 4, even though my stems on this particular data set don't start till 6. Okay? So I'm going to write down 4, 5, 6, 7, 8, and 9. Okay, everybody good so far? Lovely. Okay, so on this stem and leaf plot, I'm starting with my 60s row. I have 6, 7, 4. Put them in order for me. What do you have?
4,
Yep, 4, 6, 7. On my 7s, I have 2 and 4. So those were actually already in order, 2, 4. And I have 2, 5, 1, 6. 1, 2, 5, 6. And I got a lot of 90s. Looks like 2, 3, 4. And then what? Yeah, 2 5s, 2 6s. And 8, 9. Okay. Oops. Okay, so this is the stem and leaf plot. I know I've got these extra 4 and 5 at the top. And what we're going to do to create the back-to-back stem and leaf plot is that we trap the stems in between, like this. They don't need to go like way below the 9, but we trap the stems in between, and we take our values and we flip them around. So it says 43, so I've got the 4 in the middle, and now my 3 will go on the left-hand side of it. So over here, I will have 43 like this. And then I have 3 and 8, so I will have a 3 and then an 8. So they extend backwards away from the center. I have a 67. And then I have 4, 4, 6, and 7. And there is 0, 2, 7, 7, 8, 9, and then I have 0, 0, 4, and 4. I'm just shifting this to give me a space to write my title. So I do need a title on this. So we have the first and second exam scores. And we need to be careful how we write our notation, because we have stems in the middle now and leaves extending in both directions, don't we? So if you would like, you can take maybe the first location where they extend in both directions. The 6 would be that location. And you can specify something specifically that's there, like this. 4 is the next one. Where this means 67 on exam 1 and 64 on exam 2. And there's nothing special about me choosing that specific row. I just wanted a row that had stuff on both sides. And that's the first one I saw.
So it's like the only purpose of this graphing is like to compare?
It's a comparison graph. We're going to have some of our graphs that are standalone, kind of like the stem and leaf plot, like on its own merit over here, where it gives its own sort of impressions and you can look at it. But there's also going to be several graphs that we're going to have where their purpose is comparison, and this is one of them. I mean, so if I'm looking at this from a comparison standpoint, you can immediately see, well, the grades on the second test were significantly larger, right? I mean, like, look at all those A's. Whereas the other one, people are bunching around the B's and C's range, right? You can also say at very quick glance, I mean, very few people didn't pass the second test. Whereas on the first test, we had several people in the not passing category. If passing is C and above, which it would be for this class, you have to have a C, right? So anybody in those 60s, 50s, and 40s are all not passing that first test. Yeah, so there's lots of sort of analyses. The other thing that you can do with stem and leaf plots in general is that you can find what are called measures of central tendency. We'll talk about this in 10.4, but you can figure out what was the middle value. It's called the median. But you could count it, so we can figure out how many test grades we have, and we can just count our way down or count our way back up from that particular point to find the middle value, because we've put them in order. They just are in order all in their ones-digit pieces, basically, along their stems. Any questions on this? This was before redos existed, by the way. So that's probably part of the low. They were terrible at redos. They were not, actually. They didn't have redos. So, yeah. All right, let's look at another one. This might be our last one, probably will be.
Who came up with the redo idea? Do you know?
Yeah, so Dr. Marsh actually went to a conference. We have math conference and math ed conferences, generally speaking, yearly in different locations and so forth. She was at a conference, and somebody was presenting the idea there that they had used. She liked a lot of what they said, didn't like everything of what she said, so she tweaked it. She came back and she talked to me about it because we were teaching these 3 classes. And the whole idea that the presenter had given was about the fact that we want the students in this course, whatever the course was that they had, just like we want you in these courses, to have mastery over the material because you're going to be using it. Maybe not all of it and maybe not all the time, but you're certified to have to be able to say you know how to use all this, right? I mean, like, you leave here and you can go teach 8th grade math. You may not do so, but you're certified to do it, right? So we want to make sure that you have mastery over the material. So if I give you a test back that says that you absolutely know nothing about how to add and subtract fractions, I have a problem with being able to say, yeah, go into the schools, you can do it, because you haven't mastered that topic yet. So we do this so that you have an opportunity, the reduce process, you have an opportunity to show that you can still keep processing through that material. So yeah, that's how it came about. All right, last one. Group frequency table. This one actually shows how many times data occurs in a range of classes or intervals. One of the drawbacks to group frequency tables, as opposed to, say, like the stem and leaf plot, is that by putting things into groups, you lose the individuality concept. So we're going to group all the grades together in our traditional grade categories, because that's a nice way for us to do so. But that means that somebody who has a 60 and somebody who has a 69 look the same in this table, right? So you lose some of the individuality of the grades. But the way that this data works, or this process works, is we've got our set of data. This is the same set of data that we had from the second exam. And a grouped frequency creates equal width intervals. So for the purposes of what we're doing, the intervals make sense to make them our standard grade values. So we have an interval that's actually like 60 to 69, and 70 to 79, and 80 to 89, and 90 to 99. This is a table, so we're going to have like column headers. These are my grades, right? And the column in the middle here is a tally column. And we're simply making a tally every time we come across a grade that fits into that category. So I have 93 and 96, so those are 2 90s. 98 and 66, so I have a 90 and I have a 60. Then I have a 60 and an 80. Then I have a 90 and an 80. I have a 60 and an 80. 80 and 70. 90 and 90. When I get to 5, I can do, the hash mark sideways or diagonal. I have 90 and 90. And then I have 90 and 70. So I make my tally column. And then my last column is actually the frequency column. So this is the frequency. And what it really is just the numerical value, right? Our symbol that represents that many tally marks. So it's 3, it's 2, it's 4, and it's 9. But just like on all the other ones, I need a title. And what is the title, or what could the title be for such a graph?
The scores of the second exam.
Yeah, you can use the word scores, you can use the word grades. These are your scores on a second exam.
You just do like where something is something.
We don't need to on this one because all of the values, there's no pictures. And then there's no symbols that are representing something else. Like over here, they aren't exactly symbols maybe, but the notation itself tells you how the lines are going, you know what I mean? Like stems and leaves, what the values actually mean. That's why we needed it. Here we don't have any of that going on because all of our values are clearly outlined over here on the left. And then these are just counting in each of the other ones. Okay, so you can look at this and you can say, yep, they're 9As. So it lost specificity. I don't have each of the individual grades, but I can look at this and I can readily see exactly how many there are. Whereas if I look at, say, just a stem and leaf plot, this isn't the same data. Whoops. But if I looked at this stem and leaf plot, I'd actually have to count. I'm not saying that that's a challenging thing, but I would have to count if I was asked how many of a certain one there are. It's not just written on there, right? Whereas in this one, it actually is. It's written in. Good grief. How many there are.
Wouldn't this just be like, if we're trying to compare, isn't this just like a faster way to do it than
It is, but it loses specificity. For example, on this one, Nathan, you can't look at this and tell me the median. I can tell you that the median is, right? So like, let's see, we've got 9, 14, or 13, 14, 15, 16, 17. There's 18 grades. I can tell you that the median is somewhere around 89 to 90, but I don't really know what it is because all these 80s might be low 80s, or they might be dispersed evenly, right? All these 90s might be low 90s, but they might be high 90s. And so I don't really know what my median is by looking at this. So there are some aspects that I lose in doing this, but there's some like tidiness that I gain too, right? So there's pros and cons to doing it.
I forgot to use it, there's more to the other one.
Yeah, yeah. All right, so we'll stop there for today and we will pick up next time on histograms.